Welcome students, myself Kale Rayat Shikshan Sanstha's RBNB College Rampur. 11 Science Mathematics Part 2, Lecture number 9, Chapter number 1st, Complex Numbers, Exercise 1.4. In the previous 8 video lecture, we have completed here Exercise 1.1 and Exercise 1.3. Now today we are going to see Exercise 1.4. So now here we start firstly. What is the meaning of cube roots of unity? So cube roots of unity. Unity means one. Unity means one. So here we have to find the cube roots of unity and we assume it as a x. So x is equal to cube root of unity. We write like this. Now cubing on both sides, we have to remove this cube root. So we get here x cube is equal to 1. Carry 1 to the left hand side. So we get here x cube minus 1 is equal to 0. Okay. So it is x cube minus 1 cube, it is equal to 0. And now here we use the formula a cube minus b cube, it is equal to a minus b in second bracket a square plus ab plus b square. We know this formula. And so we get here x minus 1 in second bracket x square plus product of x and 1, that is x, and plus 1 square, that is 1, is equal to 0. Now the product of these two brackets is equal to 0 means either x minus 1 is equal to 0 or here x square plus x plus 1 is equal to 0. Now from this equation we get the value of x as x is equal to 1. Now we have to factor this quadratic equation x square plus x plus 1. But here we cannot factor this 1 so that the product of two number is 1 and addition is plus 1. So we have to use here formula method. So we compare this equation with ax square plus bx plus c. Ax square plus bx plus c. Now what are the values of a? Here a is 1, b is 1, c is also 1. And the factor using the formula method we find the root like this, x is equal to minus b plus or minus under root of b square minus 4ac upon 2a. This is the formula. So we get here x is equal to 1 and x is equal to here minus b. A, B, C, the values are 1. So put here B as a minus 1. So minus 1 plus or minus under root of B square means 1 square minus 4. A is 1, C also 1 divided by twice A. So 2 into 1. So we get here x is equal to 1 or here x is equal to minus 1 plus or minus under root of here 1 square is 1. Minus 4 into 1 that is 4 divided by 2 into 1 that is 2. So we get here x is equal to 1 or x is equal to here minus 1 plus or minus under root of minus 3 divided by here 2. So we get x is equal to 1 or x is equal to minus 1 plus or minus, we write this root of minus 3 as root 3 into root minus 1. And that root minus 1 is nothing but I, imaginary unit, divided by 2. Therefore, we get the values of x as x is equal to 1, x is equal to minus 1 plus root 3i divided by 2, and x is equal to minus 1 minus root 3i divided by 2. These are the cube roots of unity. Cube roots of unity are x is equal to 1, x is equal to minus 1 plus root 3I divided by 2, and x is equal to minus 1 minus root 3I divided by 2. Now here first root, that is 1, is a real root, and other remaining two roots are complex numbers, and those roots are complex conjugate of each other. Observe here plus sign and here minus sign. All terms are same, but only here plus and here minus. Means the sign of imaginary number are different, plus and minus, and therefore these two roots are complex conjugate of each other. Now here if we take the square of this, what happens? See, here if we take the square of this, we get this, and vice versa. We check here. So consider here minus 1 plus root 3I divided by 2 bracket square, minus 1 plus root 3I divided by 2 bracket square. So it is equal to, now we expand numerator divided by, take the square of numerator divided by square of denominator using the formula a plus b bracket square, that is a square plus twice ab plus b square. A is here minus 1 and b is root 3I. So a square means here minus 1 square plus twice a means minus 1, b means here root 3 into I, and plus b square means root 3 square into I square, and divided by here denominator square 2 square, that is 4. Okay, so here it is equal to minus 1 square is plus 1. So here plus 1, here plus and minus, it become minus 2 into root 3I, okay, plus root 3 square, it is 3, and I square is minus 1, and divided by 4. Now here we get it is equal to 1 minus 2 root 3, 1 minus 2 root 3 into I, and plus into minus, that is minus 3. So minus 3 divided by this 4. Now here 1 and minus 3, these are the real numbers, 1 and minus 3. So 1 minus 3, it is equal to minus 2. And here minus 2 into root 3I divided by 4. Now here take 2 common in the numerator. So if we take 2 common, in bracket here minus 1 and here minus root 3I divided by 4, and now here 2 ones are 2 and 2 twos are 4, so we get here minus 1 minus root 3I divided by 2, and this is nothing but the other root. See here, minus 1 minus root 3I divided by 2. So if we take the square of one complex root, we get the other, and vice versa. Means if we take the square of this, then also we get this root. So we call this as equation number first, suppose. Similarly we show that here minus 1 minus root 3I divided by 2 bracket square is equal to first complex root, means minus 1 plus root 3I divided by 2. It is homework to you. You see at home, take the square of this, we will get here this minus 1 plus root 3I divided by 2. Okay, now here the cube roots of unity are cube roots of unity are 1, this 1, then here minus 1 plus root 3I divided by 2, and this, that is minus 1 minus root 3I divided by 2. Get it? I repeat here the cube roots of unity here 1, then minus 1 plus root 3I divided by 2, and minus 1 minus root 3I divided by 2. But from equation 1, this minus 1 minus root 3I divided by 2 is nothing but here left hand side is minus 1 plus root 3I, left hand side here minus 1 plus root 3I divided by 2 bracket square. Okay, so we replace this minus 1 minus root 3I divided by 2 as minus 1 plus root 3I upon 2 bracket square. So we write here minus 1 plus root 3I divided by 2 bracket square. So the cube roots of unity are like this. Now if we assume this as a omega, if we consider this as a omega, let minus 1 plus root 3I divided by 2 is equal to, we assume this as a omega. Omega just like W, but we write like this. We take here curve. Okay, so the cube roots of unity are cube roots of unity are 1. We say this as a omega, so it is omega square. Therefore, cube roots of unity are 1 omega square. We consider this minus 1 plus root 3I upon 2 as a omega, or we may consider minus 1 minus root 3I upon 2 as a omega. Then also we get the cube roots of unity as 1 omega square. Here omega and omega square are complex roots and 1 is the real root. Okay. So note here, since omega is complex cube root of unity, complex cube root of unity, since omega is a complex cube root of unity, so omega is equal to cubic root of 1. Omega satisfy the equation that is the cube root of unity. We know that when x square minus 5x plus 6 is equal to 0, this is the quadratic equation, and x is equal to 2 and x is equal to 3, these are the roots of this equation, means 2 and 3 satisfy this equation. Similarly here omega satisfy the equation x is equal to cube root of 1. In place of x we put omega, so omega is equal to cube root of unity. So if we take here cubing on both sides, we get omega cube is equal to 1. Carry here 1, so we get here omega cube minus 1 is equal to 0. 1 means 1 cube. 1 means 1 cube. So we get here, we factor this using the formula a cube minus b cube. In the first bracket here omega minus 1, and in the second bracket omega square plus omega plus 1 is equal to 0. Using the formula a cube minus b cube. A cube minus b cube, it is a minus b. In second bracket a square plus ab and plus b square. B square means 1 square, that is 1. So we get here 2 equation, that is omega minus 1 is equal to 0, or omega square plus omega plus 1 is equal to 0. Get it? But omega not equal to 0. But omega minus 1 is equal to 0 means we get here omega is equal to 1. Or here omega square plus omega plus 1 is equal to 0. So here omega is equal to 1, and we assume here omega is a complex cube root of unity. So omega not equal to 1. Here 1 is the real, but omega not equal to 1, and therefore we get here omega square plus omega plus 1 is equal to 0. So we get very important formula, omega square plus omega plus 1 is equal to 0. Get it? Here omega minus 1 and omega square plus omega plus 1 is equal to 0 implies that either this bracket is equal to 0 or this bracket is equal to 0. If we take here omega minus 1 is equal to 0, then we get omega is equal to 1, but 1 is the real number, and we assume that omega is a complex cube root of unity, therefore omega not equal to 1, and therefore obviously the second bracket is 0, that is omega square plus omega plus 1 is equal to 0. So we get the formula, very important formula, that is omega square plus omega plus 1 is equal to 0. What is omega square? What is omega? What is 1? 1 omega and omega square, these are the cube roots of unity. 1 omega square are the cube roots of unity, so addition of there is 0. 1 plus omega square, that is equal to 0. And also we get one formula here, omega cube is equal to 1, very important. Omega cube is equal to 1. These are two important formula. Using these two formula we solve the exercise 1.4. Okay, so 1 omega and omega square, these are the cube roots of unity. Their addition is 0. Their addition is 0 and omega cube is equal to 1. So now let us try to solve exercise 1.4. Question number first. Find the value of first one here, omega to the power 18. Second one, omega to the power 21. Third one, omega to the power minus 30. Fourth one, omega to the power minus 105. Now solution of this. Solution. First, omega to the power 18. Now since here omega cube is equal to 1, just we have seen omega cube is equal to 1 and second relation is 1 plus omega square is equal to 0. So using this omega cube is equal to 1, we write this as omega to the power 3 and 3 6 are 18. 3 6 are 18. So we have to write the powers of omega in terms of 3, in terms of powers of 3. Because we know omega cube is equal to 1. So omega cube, firstly write omega to the power 3 and divide this number, given number by 3. So 3 6 are 18. So we write here 6 and using the rule of indices, if we take the product of these two we get 18. So it is equal to omega cube is 1. So 1 to the power 6 and 1 to the power 6 is 1. So this is the solution. Now second one, omega to the power 21, it is equal to, again here we write omega to the power 3 and 3 7s are 21. Okay, so we get here omega cube as a 1 and 1 to the power 7, it is again 1. 1 to the power anything, whether 0, positive number, negative number, it is 1. Next, third, omega to the power minus 30. We write it is equal to, firstly write omega to the power 3 because we know that omega cube is 1. And 3 tens are 30. Here take minus. So 3 into minus 10, that is minus 30. Now again here omega cube is 1. 1 to the power minus 10. 1 to the power anything, positive, negative, 0, it is 1. So it is equal to 1. Now fourth problem. Fourth here, omega to the power minus 105. That is equal to, firstly write omega to the power 3 and divide by 3 to this number. 3 3s are 9. 3 3s are 9. 9 and 1 10 and this 5 become 15. 3 5s are 15 and here take minus sign. Okay, 35 3s are 105, we know this. So this is equal to omega cube is 1. So 1 to the power minus 35, 1 to the power anything, that is equal to 1. So in this way we completed here question number first. Now we start here question number second. If omega is a complex cube root of unity, then show that. Question number second, if omega is a complex cube root of unity, then show that. Now first example. First example here, 2 minus omega into 2 minus omega square. 2 minus omega into 2 minus omega square is equal to 7. is equal to 7. We have to show this. We have to show that the product of two bracket is equal to 7. So we consider here left hand side. So LHS is equal to 2 minus omega into 2 minus omega square. Now we multiply by 2 to this bracket, then minus omega to same bracket. So 2 into 2, that is 4. 2 into minus omega square, minus 2 omega square. Minus omega into 2, minus 2 omega. And here minus minus plus and omega into omega square, it is omega cube. So we get here 4. Now here we take minus 2 common. Here minus 2, here minus 2. So minus 2 in the bracket, here omega square and plus this omega and plus omega cube. Now we know that since omega is a complex cube root of unity, we have the two formulas. Omega cube is equal to 1 and second one is 1 plus omega square is equal to 0. We know these formulas. We have to use this relation and solve all problems. Now here we put omega cube as 1 and from this relation omega square plus omega square plus omega, carry this 1 to right hand side, it is minus 1. And therefore it is equal to 4 into minus 2 into minus 1 and plus omega cube is 1. And so it is equal to 4 minus minus plus 2 plus 1. So 4 plus 2, 6, 6 plus 1, 7. And this is equal to right hand side, RHS. So LHS is equal to RHS. Therefore LHS is equal to RHS. Hence proved. Get it? Now second example. Second example here, 1 plus omega minus omega square to the power 6. 1 plus omega minus omega square to the power 6 is equal to 64. We have to show this. Now here we consider left hand side. LHS is equal to 1 plus omega minus omega square and to the power 6. So it is equal to, now here we have the relation omega square plus omega plus 1 is equal to 0. Important formula. Addition of cube roots of unity, that is equal to 0. And from this relation we find the value of 1 plus omega. Now here 1 plus omega, carry this omega square on the right hand side, it is minus omega square. So we put 1 plus omega as 1 plus omega, carry on the right hand side, it is minus omega square. So minus omega square and this minus omega square to the power 6. Okay, so it is equal to minus 1 omega square minus 1 omega square, it is minus 2 omega square to the power 6. Now we take here power 6 of every term, here minus to the power 6, to the power 6, omega square to the power 6. So it is equal to minus to the power 6, even power, so it is positive. Now 2 to the power 6, here 2 to the power 6 and omega to the power 2 into 6, that is 12. Okay, so here 2 to the power 6, at 2 to the power 6 means the product of 2 6 times, 2 into 2 into 2 into 2 into 2 into 2 into 2. So 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. Okay, so 2 to the power 6 is 64. Now we write here omega square as, we know here omega cube is 1. So firstly write here omega cube and then write here 3 4s are 12. We divide that 12 by 3 and write here that number. So 3 4s are 12. Again omega cube is 1. So we put here 64 into 1 to the power 4. So here 64 into 1 to the power 4 means 1. So it is equal to 64. Here answer is 64. So it is equal to RHS. And therefore LHS is equal to RHS. Hence proved. So now we see here third problem. Third problem here, we have to show that 1 plus omega to the power 3, 1 plus omega to the power 3 minus 1 plus omega square minus 1 plus omega square to the power 3, and we have to show it as a 0. Right hand side is 0. Now consider left hand side. So LHS is equal to 1 plus omega to the power 3 minus 1 plus omega square to the power 3. Now from this relation 1 plus omega, we know that omega square plus omega plus 1 is equal to 0. So 1 plus omega, carry this omega square to the right hand side, it is minus omega square. So it is equal to minus omega square to the power 3 minus here 1 plus omega square, 1 plus omega square, 1 plus omega square, carry this omega on the right hand side, it is minus omega. So it is minus omega to the power 3. So here minus to the power 3 is odd power, so it is minus, and omega to the power 2, 3 are 6. Here minus as it is, again here minus to the power 3, again it is minus, and omega to the power 3. Okay, so here minus, we write this omega to the power 6 as omega to the power 3 to the power 2, 3 to the 6. Minus and this minus become plus, and here omega cube. Now we know that omega cube is 1. So we put omega cube as 1. So minus 1 and its square plus here omega cube is 1. So it is equal to minus 1 square is 1. 1 plus 1. Minus 1 plus 1 get cancelled. So it is equal to 0. So we have to show here 0 as RHS. So it is equal to RHS. And therefore LHS is equal to RHS. LHS is equal to RHS. Hence proved. Now here next, fourth problem. Fourth problem here, we have to show that here, fourth, two plus omega square, 2 plus omega square to the power 3 minus in bracket 1 minus 3 omega plus omega square to the power 3 plus omega square to the power 3 is equal to 65. Check the problem again. Here 2 plus omega square to the power 3 minus in the bracket 1 minus 3 omega plus omega square to the power 3 is equal to 65. We have to show this. Now take here left hand side LHS. So LHS is equal to 2 plus omega square to the power 3 minus in the bracket 1 minus 3 omega plus omega square to the power 3. Since omega is a complex cube root of unity, omega cube is equal to 1, we know this. Again we know here omega square plus omega plus 1, it is equal to 0. Now from this relation to omega plus omega square, carry this 1 on the right hand side, it is minus 1. So we write here 2 minus 1 and to the power 3. Okay, minus here in this bracket here minus 3 omega, keep it as it is, but 1 plus omega square, this 1 plus omega square, 1 plus omega square, 1 plus omega square, carry this omega on the right hand side, it is equal to minus omega. So minus omega minus 3 omega to the power 3. Minus omega minus 3 omega to the power 3. So we get here 2 minus 1, that is 1. 1 to the power 3 minus here minus omega minus 3 omega. So it is minus 4 omega to the power 3. So here it is equal to 1. 1 to the power 3, that is 1, minus here minus to the power 3, it is minus 4 to the power 3 and omega to the power 3. Okay. So we get here 1 minus minus plus 4 to the power 3 means 4 into 4 into 4. 4 to the power 3. It is equal to 4 into 4 into 4. 4 4 is 16. 16 4 is 64. So it is 64 and here omega cube. We know that omega cube is 1. So we write here 1 plus 64 into omega cube is 1. So it is equal to 1 plus 64. 64 into 1, that is 64. And 1 plus 64, it is equal to 65. And this is the RHS. So it is equal to RHS. Hence LHS is equal to RHS. Hence LHS is equal to RHS. Hence proved. Now we see next problem, that is fifth problem. Fifth problem here, 3 plus 3 omega, 3 plus 3 omega plus 5 omega square to the power 6, 5 omega square to the power 6 minus 2 plus 6 omega, 2 plus 6 omega plus 2 omega square, 2 omega square to the power 3, and we have to show right hand side as a 0. So again consider here left hand side. So LHS is equal to 3 plus 3 omega plus 5 omega square to the power 6 minus 2 plus 6 omega plus 2 omega square to the power 3. So here it is equal to, now here we take 3 common, 3 in the bracket 1 plus omega and plus 5 omega square as it is minus here 2 and 2 plus omega square. So take 2 common, so 2 in the bracket 1 plus omega square. Here 2 omega square, take 2 common. Here 3 plus 3 omega, take 3 common. And plus here 6 omega as it is to the power 3. Again, since here we know that omega is a complex cube root of unity, so omega cube is equal to 1. Also we know the relation, that is omega square plus omega plus 1 is equal to 0. Using this relation, we put the values. Here 1 plus omega, 1 plus omega, carry omega square to the right hand side. And therefore we get here 3, 1 plus omega, that is minus omega square. So we write here minus 3 omega square. 1 plus omega minus omega square into 3 minus 3 omega square plus here 5 omega square. Okay, minus in the bracket 1 plus omega square, 1 plus omega square, carry omega to the right hand side, it become minus. So 1 plus omega square is minus omega into 2, that is minus 2 omega, and plus this 6 omega to the power 3. So it is equal to this 5 minus 3, 5 minus 3 it is 2. So 2 omega square, 2 omega square to the power here 6, here power 6, here power 6, and here also power 6. Minus here 6 minus 2, 6 omega minus 2 omega, that is 4 omega. So 4 omega to the power 3. Now here 2 to the power 6, 2 to the power 6 and omega to the power 2, 6 is 12. Okay. Minus 4 to the power 3 and omega to the power 3. Now 2 to the power 6, take the product of 2 6 times. So we know it is 64. We have seen in the previous example. So here 64 and omega to the power 12 we write omega cube to the power 4 minus here omega to the power 4 to the power 3, 4 into 4 into 4, 4 4 is 16, 16 4 is 64. So here 64. Now here omega cube is 1. Again here 64 as it is, here omega cube is 1, so 1 to the power 4 minus 64 into 1, 64. So we get here 1 to the power 4 is 1, so 1 into 64 it is 64 and minus this 64 it is equal to 0. So we have to show here 0, it is RHS. So LHS is equal to RHS. Therefore LHS is equal to RHS, hence proved. Now next example here. Sixth example here we have to show that A plus B omega plus C omega square. A plus B omega plus C omega square divided by C plus A omega, C plus A omega plus B omega square is equal to omega square. Is equal to omega square. We have to show this. Consider left hand side. LHS is equal to numerator A plus B omega plus C omega square divided by here C plus A omega plus B omega square. Now we have to show that it as a omega square. Right hand side is omega square. Answer should be omega square. So from this numerator we should take omega square common, so that remaining terms, this denominator and numerator should get cancelled. So we have to here use, so we write this as A into suppose 1, A into 1, that is A, plus B omega into 1 plus C omega square as it is, divided by denominator as it is, C plus A omega plus B omega square. And we know that omega is a complex cube root of unity, so 1 is equal to omega cube. Omega cube is equal to 1. So we put 1 as a omega cube. So it is equal to A into omega cube plus B omega into 1 as omega cube into omega, that is omega to the power 4. Plus here C omega square divided by C plus A omega plus B omega square. So it is equal to, now take omega square common in the numerator. Denominator as it is, that is C plus A omega plus B omega square as it is. We take here omega square common. In the bracket here A omega. Omega square outside the bracket, so here remains omega. Plus here omega square outside the bracket, so B omega. And here plus C. Now C denominator and this bracket is same, C plus A omega, here A omega plus B omega square, here B omega square. Okay, omega square outside the bracket, so here remains omega square. So this and this is same, so we cancel this. So remains here omega square, and this is nothing but the RHS. Therefore LHS is equal to RHS. Hence proved. Now next example here. Seventh example. A plus B. Seventh example. A plus B in second bracket. A omega plus B omega square. A omega plus B omega square. A omega square plus B omega, A omega square plus B omega, and right hand side is 0. We have to show 0, but here addition, plus here also plus. Okay, addition of 3 brackets, that is equal to 0. So we consider left hand side. LHS is equal to, take first bracket, that is A plus B, here plus sign, plus A omega plus B omega square plus this third bracket, that is A omega square plus B omega, is equal to 0. Remove all the round brackets. So we get here A plus B plus A omega plus B omega square plus A omega square plus B omega. A omega square plus B omega. We remove all the round brackets. Now collect the terms of A. Here A plus here A omega plus here A omega square. Okay. Now collect the terms of B. Here B plus B, here plus B omega square, and here plus B omega. Now take here A common and here B common. So we get here A in the bracket 1, here plus omega, here plus omega square, plus here take B common in the bracket, here 1 plus here omega square and plus omega. So it is equal to, since we know that omega is a complex cube root of unity, omega square plus omega plus 1 is equal to 0. Important formula. Omega square plus omega square plus omega plus 1, it is 0. So a into 0 plus b as it is here, 1 plus omega square, it also 0. So b into 0. So a into 0, 0 plus b into 0, 0, 0 plus 0, it is equal to 0, which is nothing but the RHS. Hence LHS is equal to RHS. Hence proved. Now here, eighth problem here, a minus b. Eighth problem, a minus b. In second bracket here, a minus b omega. A minus b omega. In the third bracket here, a minus b omega square. A minus b omega square is equal to, right hand side is a cube minus b cube. We have to show that this as a cube minus b cube. So take here left hand side. LHS is equal to a minus b into a minus b omega into a minus b omega square. Now here it is the product of three brackets. So when we take the product of three numbers or three brackets, firstly take the product of two numbers or two brackets. So we take the product of these two brackets. First bracket as it is a minus b, in the second bracket a into a square, a into minus b omega minus a b omega square. Okay, a into a square, here minus sign, a into b, ab and omega square. Now multiply by minus b omega. So here minus a into b omega, ab omega. Then here minus and minus become plus, b omega into b omega square. So b square omega into omega square, it is omega cube. Okay. So here it is equal to a minus b. In second bracket this a square as it is, here we take minus sign common, also ab common. Okay, and in bracket here omega square plus omega, here we take minus sign common, ab common, here omega square plus this omega plus here b square as it is into omega cube. Now since omega is a complex cube root of unity, we know that omega cube is equal to 1. Also the second relation, omega square plus omega plus 1 is equal to 0. So omega square plus omega square plus omega, carry this 1 to right hand side, it is minus 1. So put here minus 1. So we get here a minus b, in the second bracket a square, here minus ab and omega square plus omega, it is minus 1 plus here b square and omega cube is 1. So here it is 1. So we get here a minus b, in the second bracket here a square minus minus plus ab and here plus b square. And this is nothing but the formula of a cube minus b cube. You recall the formula. So it is equal to a cube minus b cube, and this is nothing but the RHS. Hence LHS is equal to RHS. Hence proved. Hence proved. So now here only there is one problem in this question number 2, and it is homework to you. Ninth problem here. Ninth problem you solve yourself, that is a plus b bracket square, a plus b bracket square plus a omega plus b omega square, a omega plus b omega square bracket square, a omega plus b omega square bracket square, a omega square plus b omega, a omega square plus b omega bracket square, and it is equal to, we have to show that it as a 6ab. We have to show this as a 6ab. Very easy example. Here take the a plus b bracket square using the formula a square plus twice ab plus b square, and use the same formula to this and this also, and use this relation. omega square plus omega plus 1 is equal to 0 and omega cube is equal to 1. We get here answer 6AB. So in this way we completed here question number first and question number second in exercise 1.4. Now here only question number 3 and question number 4 we have to solve, and we see in the next period. So we stop here. Thank you.